Physics class, welcome. We're going to talk about powers of 10. And what I'd like you to do first is I'd like you to label powers of 10 in your 3-ring binder notebook. And just keep track of any main ideas that you might have about this. Before you go any farther, I'd like you to go right here to this particular YouTube site, that particular YouTube address. I have it posted down below under the published on date as well. You can click that link. And I'd like you to stop this video and watch that one before you continue on to this video. So after you watch that video, come on back here and continue on to this one. So first, I hope you watched the video, and now I want to tell you that powers of 10 is also known as orders of magnitude. And I tell you that because on the last Regents exam, they had a powers of 10 question, and they actually called it orders of magnitude. So it's important that you know it both ways. So if I had something like 10 to the second, what power of 10 is that? Well, that's 10 to the second power. What would be an order of magnitude greater? 10 to the third. What would be 2 orders of magnitude greater? 10 to the fifth. Hopefully you saw from the video that going from 10 to the second 10 to the third. 10 to the third is 10 times greater than 10 to the second. 10 times greater. So it's a huge difference. Going from 10 to the third to 10 to the fifth, that's 10 times 10 greater. Because you go from the third to the fourth, and then the fourth from the fifth. This is 100 times greater. Hopefully you can see that increasing by a power of 10 or an order of magnitude has a dramatic effect. Now, what I'm looking at this point is going to be what we find in our reference table. Right here, prefixes of powers of 10. What I want to note about this is, first off, it is in your reference table. If you have your reference table already, I'd encourage you to look on. And if you don't have it yet, perhaps you want to take a screenshot and print this out and add it to your notebook, because it deals with all the major prefixes of 10, all of the major powers of 10 that we deal with most often, and it puts them all in one spot for us. So let's take a peek at what's going on. Notice that we have 10 to the minus 1, 10 to the minus 2, 10 to the minus 3, but there's no 10 to the 0. Somewhere in there is actually 10 to the 0 power. 10 to the 0, any number to the 0, is equal to 1. So what we're saying is that there is a 10 to the 0 power that has no prefix in front of it. On this column here, these are all metric prefixes. So if we pick a unit, let's say our unit is the gram. You may have heard of that before. You can put a prefix in front of that, like kilogram. Now the gram itself is a 10 to the 0 power. It's the base unit. But the kilogram, you ask yourself, what's a kilogram? Well, a kilogram, if you look over here, can be abbreviated with the symbol K. So I could write it like this: K for kilo, G for gram, and that means that's 10 to the third grams. So I could say that 1 kilogram, in place of kilo says that's 10 to the third. Actually, I want to make that arrow go to the 10 to the third spot. So the kilo is the times 10 to the third, and then I copy down grams. Now what does that total up to? Well, if you know anything about powers of 10, 10 to the third means you take the 1 that's sitting there and you move the decimal 3 places, making the number bigger. So right now there's an invisible inherent decimal right after the 1. If you move it 3 times greater, there's 1 move of the decimal, 2 moves, 3 moves of the decimal. So that means 1 kilogram is 1,000 grams. Now we're going to try a few more of these just to take a peek and see what's going on. Ready for another example? Let's take 70 mg. M, in this case, is standing for mega, and G is standing for grams. And I ask you, let's change that over to regular old grams. So how many grams is that? Well, mega, according to this, the symbol M, is 10 to the 6th. So that means the mega is actually standing for multiplying by 10 to the 6th grams. So that's how many grams it is. It's 70 times 10 to the 6th. How do we get rid of this sort of scientific notation and actually express that as a really huge number? We take the 70 and we move the decimal 6 places, making it bigger. 1, 2, 3, 4, 5, 6, and put it down in unit of grams. So that number is 70 million grams. If you didn't catch that, rewind it and watch it again. Let's try one more. Let's start off with the idea of this symbol. 62. And what is that symbol? This symbol right here. We come over and we take a peek. We say, oh, there it is right there. It stands for micro. And what does micro mean? It says 10 to the minus 6. So that means if I wanted to figure out how many grams this is, I would substitute in that micro means times 10 to the negative 6th grams. Now, how do I put that in a number that's going to be extremely small? Well, I'm going to move my decimal one more time, just like we said before, 6 spaces. But that little negative sign right there means that I'm going to be moving it the other direction, making the number smaller instead of bigger. So I start off with the number 62, and I'm moving a decimal from right here, 1, 2, 3, 4, 5, 6. So those are all zeros before the 62. So you can see why we actually don't like to write the number like long out like that, because there's so many zeros, it's just cumbersome. It's nicer to have it this way in scientific notation. But if I wanted it out of that kind of notation, I have to write it in this longer way. So that actually comes out to be 0.0000062 grams. Okay, now I have a question for you. How many orders of magnitude, I'll abbreviate magnitude, separate the micro prefix and the milli prefix? So here's the micro prefix, here's the milli prefix. You can see the micro prefix is 10 to the minus 6th, milli prefix is 10 to the minus 3rd. How many orders of magnitude separate them? Or how many powers of 10? Remember, this idea of orders of magnitude is the same thing as powers of 10. What do you think? Pause the video, take a shot at it before I tell you. Did you pause it? Hopefully you did, because here's the answer. It's 3. 3 orders of magnitude separate them. 3 powers of 10. We can count down from minus 3 to minus 4, minus 5, minus 6. So 3 powers of orders of magnitude or powers of 10 separate those two. There's a similar question like that on the worksheet. So let's take a look at the worksheet for a second. Here's the homework, powers of 10 homework, and you can see the very first question is about how many orders of magnitude separate kilo and giga. You can take the knowledge you just learned in the last example and try to answer that question. Now, within the topic of powers of 10, we also have the idea of scientific notation. And you should have seen this idea before. If you haven't, go ahead and get the idea down now. Scientific notation is the idea that if you have a number, like the number 1,763, usually put a comma right there, you can express it as a power of 10 by taking the inherent decimal, which if it's not represented sits at the end of the number, and moving it in between the first and second digit as long as that first digit is non-zero. So I move the decimal over in between the 1 and the 7, write the number like that, but obviously they're not the same number. So how many times would I have to move this decimal right here to make that the same number as it originally was over here? Well, I'd have to move the decimal 1, 2, 3 times. So to make them equivalent, you would say that that's the same thing as multiplying by 10 to the 3rd. So this number, 1,763, in scientific notation is equivalent to 1.763 times 10 to the 3rd. Now what I like to do, instead of writing times 10 to the 3rd like that, is I like to use what I call calculator notation. If you take a look at your calculator, you'll see that some calculators have times 10 to the third. Other ones have a capital E. And some of them have two capital E's. I could rewrite this in calculator notation like so. 1.763 E3. And what does E3 mean? It means what I circle right there, times 10 to the third. We're going to use that notation a lot in class because that's the same notation that our calculator uses. So make sure you jot it down in your notebook so you have something to refer to when we start using it more often. And by the way, it should be not notion, but notation. Same thing up here. My apologies. Let's try another one. Let's say we have a small number like this. 0.00156. Now that's a very small number, just like large numbers are a pain to carry around, so are small numbers. So again, we're going to move our decimal, which is expressed right here, to be in between the first and second non-zero digit. So that means I'm going to hike my decimal between the 1 and the 5. And how many times did I move it? Well, it was 1 time, 2 times, 3 times. That means I'm going to multiply by 10 to the third again. But if I write it like that, it sounds like I got to make the number bigger to take it out of scientific notation, so it's actually times 10 to the minus third. What that means is when I take it out of scientific notation, I move my decimal backward 3 spaces, backward to what I have up in this example. Once again, in my new notation, using calculator notation, I would write it like this. There's 2 examples with scientific notation for you. That covers all the basics that you're going to be needing for the worksheet that I presented to you. And now you can answer the rest of the worksheet, which is due tomorrow in class. Good luck with it. If you need to, watch the video again or the Powers of 10 video that I referred you to. Thanks. Mr. Nale.